tonight I'm here at LUUG with Tom, and can you explain how useful your background in mathematics has been and how you apply it to your work?
Well, basically, mathematics is the underpinning of everything that I've done, so it's really been extremely important. The first piece of software I developed, Cojoint Action, is actually entirely based on a mathematical model. And if I hadn't done my maths degree, I don't think I really would have been able to actually build the software itself. So it's kind of the underpinning of the software, and also I think the ideas in mathematics and the way that you're taught are extremely useful in games development and design because they teach you to solve problems. And even when you're developing middleware or developing games, that's something which is, I think, quite a useful skill.
I see. And Tom, what are Orbit and Action, and what do they add to the game developer?
So Orbit and Action are middleware that I've developed, which are currently available for Unity. Orbit is adaptive AI software. So it's software that allows a games designer to train his AI to adjust its behavior based on information that's collected about the user. And Action is skill modeling software. So it allows you to build a complex network of skills that actually interact with each other. So it's trying to build on the ideas that you see in RPGs, for example, but allowing for much more detail and realism by allowing those skills to actually be related to each other and affect each other. In terms of what they add to a games developer, I think they give you tools which can add extra realism, but more than that, I think they allow you to understand the user a lot better. And if you understand your user, then I think it's easier to create content which is better suited for them. So, yeah.
That sounds great. And what were your aims when launching Cojoint, and how have those aims evolved with the release of products like Orbit and Action?
Well, when I started Cojoint, it was really because I felt that my first piece of software, Cojoint Action, would be useful for games developers. So the aim of when I started off Cojoint was really to see if that was really true, that developers would see value to it. And it was also about exploring these ideas in personalization in gaming. So seeing what different types of games could be made with that sort of software. Now, as it's evolved, I think that I understand those ideas a lot better. And I feel that I'm more focused on what I think the software is useful for. And that is really honed in on that idea of adaptive content, responsive content. So considering what our users are doing and then trying to make our game actually react to that. And that sort of putting those pieces of software together has sort of allowed me to understand that concept a lot better. And I feel that's what I'm really trying to focus on at the moment.
I see, thank you. And in your opinion, why are meetups like this important to independent developers?
For me, I get a lot out of getting a chance to meet with like-minded people. It's always interesting to hear what other people's projects are, because then you can understand what game developers are looking into at the moment, you can understand trends, you can understand how your tools could be better suited for what they need. Because ultimately, at the end of the day, it's my job to help things that actually make game developers' life easier. So it's talking with like-minded people, understanding their projects, and also getting feedback upon what I'm doing is extremely helpful so that I can appreciate, am I actually solving a real-world problem here? It's also just nice to be social. I mean, it's a big aspect, especially with game developers. It's so easy to get stuck in your office or your basement or your bedroom, in my case, and not actually socialize outside of the internet. So getting a chance to speak with people is always fantastic, and it's a good place to rally and understand the people who are like-minded.
And finally, what will you be talking about at today's LUUG?
So today's LUUG, the title of my presentation is Personalised Gaming, so creating adaptive responsive games in Unity. So the idea behind the talk is to demonstrate a framework for creating personalised content in your games. So creating elements and game mechanics in your games that actually adapt their behaviour based on information collected about the user. And then I'm going to go on to demonstrate that sort of working in a Unity environment. So actually how you can incorporate these things into Unity with some of my own software and also other pieces of software which are easily integrated with Unity.
Thank you so much for your time, Tom. Thank you.
No problem. Thank you very much.
Okay, guys, we'll make a start for what is now the 30th LUUG. Cool. I'm going to keep this short and sweet. Tonight we've got Tom, who's going to be talking about personalised gaming, but we'll hear more about that in a moment. We're going to be taking a break around about when Tom finishes. So again, anyone who wants to do an open mic slot, come and grab me at the break and I'll queue you up. Then Dan's going to be talking about procedural worlds within Unity. I don't know if any of you guys have seen some of the stuff Dan posted. Yeah. So Dan will be going through that. We've also got the first, well, to be honest, the second of something I want to keep going, which is a student spotlight. So how many people here are students, just so I can get an idea of... Cool. So if you want the opportunity to show your work off, to possibly look for people giving you maybe placements, internships, or if you've just graduated, we're going to be holding a student spotlight each LUUG. And from university to university, it doesn't matter where you're from, everyone's equal in the eyes of Unity. Because it's, doesn't matter, there's a joke there. But tonight we've got Anton, who's going to be showing us some of his work. And if I didn't go backwards, then the open mic, and then a pub, of which I don't know the name, but it's around the corner somewhere. So I'm going to be very quiet now and shut up, and we will have Tom come up.
My mouse. I get the feeling my mouse is just about to run out of batteries, which is, yep, absolutely typical. So there you go. So thank you very much, Dan and Lloyd, for inviting me, for starters. As some of you know, my name is Tom Matcham. I'm going to speak about personalised gaming, so creating dynamic, responsive games in Unity. So I think it's useful just to summarise what this talk will be about first of all, and the idea really is to make games that connect with the user by analysing their behaviour and then getting our content to respond to what we've actually learnt about them. So it's also going to be based on a white paper that I've written called A Framework for the Creation of Personalised Content in Video Games. So I'm going to be putting these slides up online afterwards. If you go and check out, that will hyperlink you to that. I'm also be putting up a link to all the other content that I'll be going through in this talk, the Twine files and the Unity projects as well and things like that. So I'll link that on my Twitter and the Google Meetup page as well. So a natural question that some of you may be asking is why I should care about making personalised games. And the answer that I would provide is that there are proven benefits as demonstrated by some very successful games in doing so. So some examples that come to mind for me are things like The Sims, Grand Theft Auto 5, Minecraft. They all included these sort of personalised game mechanics, and they all benefit from fantastic player engagement and also excellent audience retention rates. And the reason why they do that is because users get a chance to be creative, they get a chance to see the impact that they're having on the world that they're creating, and I've forgotten the last point, but that's no problem. So to summarise, basically users will care more about the games that you're making if you can personalise their experience. You're going to connect better with the user. So now hopefully I've convinced you to take note of what I'm saying. We need to understand what I mean by personalisation in the first place. So a definition which I like is that it's the accommodation of differences between individuals. And this is quite a problem for games developers because it's very difficult to cater for lots of different people. And I think the approach that most games developers take is that we're just going to ignore that. And especially with the big games developers, they're moving more and more towards cinematic experiences, where it's almost like emulating the process that you go through watching a film. Now, I sort of like to think on the other end of the spectrum where we say, well, let's see what we can do to actually help out personalise our content for our users. So the next natural question that you're probably wondering is how are we actually going to do this? And there are a couple of ways that I've considered anyway. The first way is to give a user great creative freedom. And this is what Minecraft did extremely well, and saying, here's a set of tools, here's a sandbox, now do whatever you want. And it allows people to create a world that they deeply care about. Now, something else that you might see, but not so frequently, is the idea of creating interpretive elements in your games. So leaving a story, or including story elements that you don't explain. And that means that the user has to imprint their own opinion about what's going on in the game. And so you sort of you can connect with the user that way by saying, this experience is now mine because I'm saying what really happened. But the approach that I'm actually going to be talking about today is a more analytical and technical approach, and that's by analysing user data at runtime. So in order to sort of explore this solution in more detail, it becomes useful to sort of consider a few definitions and tools, and the first of which that I'm going to be mentioning is what I've called a player-game interaction model. And it's basically an abstraction of the way that a game and a player interface with each other. Now, obviously a game isn't structured in this sort of manner that you have like this input processing unit and an event processing unit, but it's basically what actually occurs when you're running a game, and it's quite useful when we're considering the subject of personalisation. So the way this obviously works is that the player provides input in the form of keystrokes and mouse button presses, etc., and then an input processing unit decides what that event means in terms of the state of the game. So in a first-person shooter, if I click my left mouse button whilst my cursor is aimed at a screen, then the input processor will determine that that means an enemy has been shot. So then what happens is that what I've called the event processing unit determines what response to give back to the player. So in a simple example, as in the first-person example I've just provided, that would mean that we play a gunshot sound or we provide a blood decal, and then more interestingly, we might alert other enemies to go investigate. If you consider this model, there actually turns out to be quite an interesting measure of each of these interactions, which I've called context sensitivity. So context sensitivity is the amount with which a player game interaction is affected by previous interactions. So you get a sort of a spectrum of results when you consider interactions in this sort of manner. So context insensitive events are the ones which have a finite and fixed response. So for example, in a simple game, it's like triggering a cutscene. The content of the cutscene is fixed when the game is compiled, and all that the cutscene cares about is the fact that you triggered it. It doesn't care about the way that you behaved beforehand. But on the other end of the spectrum, we have context-sensitive interactions, which do care about the way you've played beforehand. So taking the cutscene example, a context-sensitive cutscene would adapt its content dependent upon the way that you've played before that point. So when you start to view interactions with this measure or in this light, it becomes apparent that context-insensitive interactions, the one which don't actually depend on what you've done before, contain quite a lot of useful information about the way that the user is actually playing the game. So a trivial example will be, again, a player shooting an enemy. Now, if you actually analyse that interaction, that will tell you what weaponry they're using, what position they were in to do so in a strategic or tactical way, if they're using cover, lots of different factors that standard analytics would sort of tell you, which actually tells you a lot about a lot of useful information about the player itself. And on the other hand, context-sensitive responses are more summaries of the way that the way that the user has played before. We're taking into account all of the information that we have about the player so far, and then we're going to adapt our content. So this creates quite an interesting symbiotic relationship, where if you collect data from context-insensitive events and then use that in your context-sensitive responses, you can produce some quite some high-quality personalised information and mechanics for your users. So if we want to be considering context-insensitive interactions, then it makes sense to try and put a framework around understanding how to break down that data into the bits that we actually want to consider. So the way I do this in my paper was to consider the observational, the methodological, and the motivational components of that data. So observational is what the player actually did. So I shot an enemy, or the player shoots an enemy. Methodological is how they did it. So I shot the player with a sniper rifle. And then motivational, which I think is the most important of those components, tells you why they did it. And this is really the piece of information that we're interested in. So a motivational would be the player shot an enemy with a sniper rifle because he's particularly skilled with rifles, and he felt under pressure to kill an enemy, for example. So if we can collect that data about a player's motivations, we have a very good source of information about what the user is really doing. And I'll be going into a bit more detail in a moment about how we can actually quantify that data. So just to highlight this, there's a typo there. That should say insensitive, by the way. But just to highlight this sort of structure of the data, the motivations are sort of at the core of it, and then they sort of proliferate out. So the motivations really usually determine the method that the player will be using during the game, and the motivation and the method determines what we observe. So really, a key to all of this is motivations. So I've put a star on this slide so that if you're all half asleep, then this would be the thing that I'd like you to remember. But if we put this all in a framework, what I'm really trying to say is that if we can understand the motivations of the player by processing context-insensitive interactions, and then use that processed data to accommodate for different playstyles of the user, then we're going to make a game which people will really care about, because we're going to actually make a game that reflects their own behaviour. So that's the take-home message, I would say. So I mentioned this a little bit earlier, that there's a problem with this sort of model, because by its very nature, motivational data is very qualitative, so it's really descriptive. And another problem is that users don't necessarily know what their motivations are. They're usually enacted at a subconscious level. So immediately we have a problem to solve of how we're actually going to get this data in numbers. And so the approach that I would present is to consider collecting data in two different varieties. So collecting data about factors which are external to the player and factors which are internal to the player. And I'll explain what that means in a moment. And that's hence the name, player external and internal modelling. So player external modelling is very similar to the use of standard analytics, but instead trying to process it at runtime. So we're collecting things like, is the player using cover? What routes are they taking through the map? What weapons are they using? How many enemies are they killing per minute or whatever? So these are the standard things that we use to collecting analytics. But then if we do some pre-analysis before we release the game, so as we're designing, we can then collect that data at runtime and then classify it using a machine learning algorithm, for example, and say, well, this is probably the reason why they do it, so we can customize our content based on that fact. So player internal modeling is my own personal approach to this, solving this problem, is the idea of actually mathematically modeling the player itself. And we do so by considering the skills and traits of the user or the player that are important to the actual game experience. And then we, as input to this model, we consider the actions that they're actually performing in the game. We break that down into the skills that are relevant to that action, and then we feed that into the model. And then the model itself tells us what skills are important to this user. So the underlying assumption is that if we know what skill levels the user are important to the user, then we probably know about their motivations as well, because it's likely that they're going to act where their high skill levels are. So each of these approaches have strengths and weaknesses. Now, with player external modelling, it's very useful for understanding player strategy, because we can collect a lot of useful information about, like I was mentioning, cover types, strategic information, if they're near to strategic waypoints. But some might argue that this data is actually less fundamental than the data you're collecting in an internal model of the player, because it's likely that their skill set is actually driving the strategic choices that they're making as they're playing your game. So on the other hand, with player internal modelling, this requires you to have knowledge of the skills that are relevant to your game, so you need to actually derive a mathematical model of what you're interested in. But this really simplifies analysis, because these sort of data sets where you're just considering sort of numbers of skills are very easy to process with an appropriate machine learning algorithm. So that's really the theoretical content of what I'd like to talk about today. And what I really wanted to bring home is the fact that this is not just theory, this is something which can be applied in games right now. And the way I'm going to hopefully demonstrate that is with an example of nonlinear narratives, a model of the moral traits of a user, and then how we can combine those two things together to create what I think is quite a potent and extremely interesting gameplay mechanic. And then finally looking at adaptive AI in a game prototype I'm working on called Apotheosis. So nonlinear narrative is quite old. It's been around for years and years and years. I actually remember as a child reading these nonlinear sort of books. I don't know if anyone else remember those. Yeah, they were fantastic. What you do is that you'd be given a choice and you'd say, turn to page 100 if you want to kill this enemy, or turn to page 50 if you want to run away. And they were also very popular in the early 90s and early mid-90s, and probably a bit earlier than that actually, in text-based adventure games, where you'd sort of be typing in commands. But they've sort of gone out of fashion a little bit, and they're only really featured in RPGs. And I think the reason why that is because there's been a movement towards trees in game design. So everything seems to be about trees, and I think Bungie are to blame for that. So ever since they sort of released behavior trees, it's like, if you want to use a finite state machine, then you're old, so don't bother. But the thing with nonlinear narrative is that they just don't fit into trees very well. So when you're using a graph to represent a nonlinear story, it's very easy to get back to a place that you've already been before, or to go to traverse several routes to a particular node. But with a tree, if you're trying to do something like that, you're going to repeat yourself endlessly, and that means the size of your trees is going to be huge. But fortunately, there's actually some quite good software available at the moment to create nonlinear stories, and it's called Twine. That's a bit zoomed in. Has anyone heard of Twine? Okay. So Twine basically allows you to create a passage, and then this is an example I'll be showing in a moment. It allows you to create a passage, and then you sort of determine the other passages that passage is going to link to by using these square brackets, which I can't get down to. There we go. So the reason why I've actually brought this up is because it's very easy to parse the save type for a Twine file in Unity. So that's what I've done. So my point being that you can actually create nonlinear stories and use them as your dialogue in Unity very easily without having to create some specialized tools. So for the purpose of this talk, I've created a nonlinear story called Video Game Lecturer Simulator, as some of you may have seen. I really, really hope I don't offend any of the lecturers in here. Oh, that's a shame. That's going to be cut off a bit. Okay, that's not a problem. I'll put this up on my website so you can take a look. later on. But you're basically playing a video game lecturer who has to deal with annoying students asking stupid problems. And then, that's a shame about the GUI, but you had to play it in your own time. But the idea being that you can go to several different, there's many different routes to different story elements in the game. So that's a bit embarrassing having that up when it's all buggy. So the idea is, the reason why I showed you this is because personalisation, non-linear narratives are quite a good personalisation tool in some respects, but the problem is that there's not really that much adaptation of the content. So the responses that you get from a non-linear story are usually quite context insensitive. So the next example does this absolutely fantastically well in creating a context-sensitive non-linear story. I don't know if anyone's heard of this game called At Gunpoint. Has anyone heard of it? Nope. It's by an American game designer called Evan Hill. And it's a non-linear Twine game, but it actually uses a player internal model. It's a very simplistic one, but it has a fantastic effect. So the way that the game works is that it evaluates your own mood and the NPC's mood based on the choices that you made earlier on in the game. Now, I've counted up from the Twine file that it's only a 67 node network, but Evan tells me, you have to take my word for it, that there's over 2.7 trillion different story possibilities based on this node. So I'm just going to show you the Twine file for it now, because he's made this all open source, so you can go and take a look at it. But for a story with 2.7 trillion different possibilities, it's not actually that big. And I can show you it now. So the way that Twine works, usually, is that it plays in a browser. So you play your games like that. And I'm just turning down. Okay, that's a bit better. Sorry, I should have set this up. So it's a standard sort of non-linear story at the first. Apologies for this. This is the interesting part. So now what you get is you get a choice of things that you can say to this opponent. The idea of the game is that someone is pointing a gun at your head, and you've got to stop them from pointing a gun at your head. But you also have someone's coming to rescue you, so you have to consider in the time as well. So you're basically trying to stall them or stop them from killing you until you can get rescued. And at each node in the dialogue, there are these 9 choices here where you can tell the truth, or you can lie, or you can stall. And this all feeds into the composure and the anger of your opponent. So that's how this is all evaluated, giving these different personalised choices. So it's a very clever system, and I was very impressed by this. It really got my imagination going when I first saw this. So At Gunpoint sort of provides a sort of a morality model, but it's a bit binary. It's very limited. It only considers integers between 0 and 10. So we can actually do a bit better than this if we consider morality modelling as more of a player internal model. So we all know that games tend to do morality pretty badly. It tends to be fairly binary. So, for example, in Bioshock, if you kill one little sister, then that's it, you're bad. Life's a little bit more nuanced than that. So it makes sense to create a model which has a lot more factors to it. Morality is a multi-factored thing. So we all know people who are good in some respects and bad in others. And so it would be nice to create a model which actually reflects what we see in reality. So I've actually used a piece of software I've developed called Coadjoint Orbit, which takes all of the different moral traits that we're going to be evaluating, and it's a machine learning tool that boils them down into a classification. So it becomes quite easy for a developer or designer to say, okay, we only have to accommodate for 3 different classification types. Now I'm hoping this actually shows up. Oh, my apologies, I haven't got the scene open. Oh, typical. You should always accommodate for lower resolutions. Terrible. But I hope you can see, this is really terrible, I'm sorry about this, but you can see that we're considering sort of kindness, greediness, truthfulness, these sort of factors. So we've got many factors that are going into this model. The game time is there for a sort of decaying effect on the skills, the traits. So if you perform something bad in real life, so if you're 16 and you make an idiotic mistake, it's not so harsh in other people's minds when you're 20, so that's what's going to be simulated. But these buttons down here are representing things that you could do in this sort of play example that will affect your morality. So I'm going to be really bad, and I'm going to bribe someone, and immediately I'm a really bad person. And let's get angry, and let's get jealous about my girlfriend flirting. But then suppose that, so what's happening is that my software is evaluating this as a bad person. So the idea being that we have lots of factors and we can summarize them all using machine learning. And then perhaps let's say that later on in my life I decide I want to repent and be a good person, so I'm going to adopt 7 children now. And then I'm now very good. So this is only a toy example, and I did a video of this on YouTube to show just how I set it up. It didn't take me much time really at all. But if you actually spent more time thinking about this, of what was really important and what should go into your model, then this is actually quite a powerful technique, I think, in a game. And this sort of shows that the technology is available to do this at the moment. So we've seen nonlinear story elements, and we've also seen a reality model. And what I would really like to see, if we took a game like At Gunpoint, put it into Unity, and then instead of having a simple sort of integer evaluation of someone's anger or composure and just using simple if statements, wouldn't it be good, I think, if we could use an interesting model of multi-factors and use that in a non-linear story to affect dialogue and how the narrator tells the story itself. That's something which I think is extremely exciting, and I would personally love to see something like that in a game. So the last example that I'm going to be giving is a prototype of a game that I'm working on at the moment called Apotheosis. And this is kind of different from the examples I've given before, because this is more focused on agent behavior. So what's hopefully going to make Apotheosis unique is the fact that the AI adapts its own strategy based on your strategy. So it's a turn-based sort of fantasy fighting game where the AI is actually learning about the way that you're attacking and defending and says, okay, what's the best way that I can counteract that? And then moreover, the enemies that once you defeat one enemy, the next enemy that you're going to face is going to be chosen to provide the best challenge to you as well. So add-ons to a skeleton, for example, or if we're going to give you a golem or something like that. So let me just flash this up. So I hope you can see this, but that's a skeleton there, and he's going to attack me. And just for the purpose of this demo, this is only created in about 7 days, so please bear with the lack of animation and things like that. But this skeleton's going to attack me at first, and I'm just going to try and dodge all of his attacks. And then when I attack him, I'm just going to use slow, high damage attacks. The idea being that when he comes to attack me again, he'll know that I dodged all of his attacks in the previous round and will try and move around more to demonstrate that he is aware of that and to try and make me better at dodging, or prove that I'm better at dodging than he is attacking. And then when I come to attack him, he's going to parry my attacks, hopefully. So basically trying to interrupt my attack before I get to attack him. So I put up a little GUI at the top as well to show his evaluation of his opinion of me at the time. So he's doing attacks in one place, and I'm just going to dodge. And then he's going back, so it's my turn to attack now, and I'm just going to do some slow attacks here. Okay, that'll do. And then on the GUI, you notice he thinks I'm dodging a lot, so now he's going to move around more to try and get me whilst I'm dodging. And as you can see, I'm terrible at my own game, so he's done quite well. And then again, when I go and attack him, he says he noticed that I'm slow, so there you go, he's parried my attack. And also he's moving around a bit more to try and dodge mine. So again, it's a simple prototype, but hopefully it demonstrates the point I'm trying to get across, that when the AI sort of changes its behavior and adapts its behavior based on knowledge it's gained about me, that's quite a strong idea and something which I think is potentially quite useful. So, in summary of the points that I would really like to get across, if you can understand your users' motivations, then I think you're going to have some quite powerful information that is useful in your game, that will make people care about your games more. If you can somehow use that information in a game to include more context-sensitive interactions in your game, then you're probably going to benefit from that as well. And then the final point I'd like to make is that this isn't some fantasy, this isn't an idea that's out of everyone's reach. It's possible to incorporate these things in your games right now. There's technology that you could go and look up all over the internet that will allow you to do these sort of things. And I also have tried my best to provide a solution as well for Unity developers. So thank you very much for listening to my talk. If anyone is interested in this concept, then my own software, Action and Orbit, is available in the Unity Asset Store now, so you can use some of the software that I've demonstrated in this talk. I'm more than happy to take emails and have a chat with you there. So tom@coadjoint is my email address, and my Twitter handle is coadjointtom. So on my Twitter account, I'll post a link to a web page which will contain basically everything in this talk. So thank you very much.
I'm here tonight with Dan, CTO of Just a Pixel, and CEO Roberta Saliani. Would you guys give us a quick overview of your backgrounds, please?
Sure. I used to be a tech director at an advertising company called Happy Finish. Was there for about a year. Before that, I was a Greenwich Uni student studying games development, and then I moved down to Brighton with Rob and set up Just a Pixel about a year ago, I'd say. Yeah, about a year ago. Yeah, and we've been doing that ever since.
I used to be a project lead at Electronic Arts, formerly Playfish, and then they decided to stop developing the same social online, so they just shut the studio, and I was like, okay, what should I do now? And we started our own studio together.
Blessing in disguise.
Yeah, it was pretty good. It was one of those leaps of faith, and it actually turned out to be quite nice.
Went
And
well.
yeah, we moved down to Brighton because, I mean, we wanted a change. London became a little bit too busy for us, and we wanted to be able to get to meet all the tech companies that moved down to Brighton and were already existing there. So that's...
It was nice. Nice different change of atmosphere. I get to go to the beach every day now. It's nice.
Sounds great. Roberta, could you give our viewers a brief overview of Just a Pixel?
Just a Pixel is literally us in that we are the only two permanent staff, and then we generally tend to hire freelancers to deal with art, and sometimes it's sound and anything that we could need extra. Sometimes it's even CGI. We take care of games, so we make video games. Both the last one that we made, which is called Light, is being published by Team 17. We take care also of applications, so we make iOS, Android applications, pretty much all platforms applications, and we're now generation.
Yes, procedural generation. I'm starting to learn about it, so I wanted to do a talk about sort of explaining how I've got what I have already working, so I just kind of want to go over the basics. Maybe answer any questions if people have them. I don't know. I found no information online about tutorials for procedural generation, so I just wanted to sort of say there is stuff out here. I want people talking about it.
And Roberta, what were you doing before you joined? Wait, no, you've already answered that. Roberta, what is your day-to-day life like being CEO of Just a Pixel? Sorry. Roberta, what is your day-to-day life like being at... Wait, one more time. Roberta, what is your day-to-day life like being CEO of Just a Pixel?
I take business development. Sometimes, like for instance, when we were developing Light, I was making the design for the levels, and I do a lot of accounting, even though I don't want to do it. I take care of pretty much, yes, all the freelancers, and I project lead, and I help him with scheduling and prioritizing tasks and everything that needs some extra person to do that job. I'd probably just jump on it and do it. That's pretty much
management guru, I'd say.
That's my day-to-day life.
I see. And Dan, we're all very excited about Light. As a developer, do you find that there's an extra element of pressure due to the hype? And if so, how do you deal with it?
There's a lot of pressure. I don't really deal with it that well. I'm quite shy and timid as a person, so I don't really like talking about my work. I really am proud of it, and I want people to play it and stuff, but at the same time, it terrifies me, the idea of people giving me bad feedback. But at the same time, I understand that's part of the process. I want to make the game better, and I need to get that bad feedback to make it better. Hopefully there won't be any bad feedback. I don't think there should be, but it's still, I guarantee there's going to be someone who doesn't like something about something.
I think it's really, really hard to deal with the first game that we make as a studio being published, because I mean the first thing that you think is, if we made this game like alone, it would have been probably okay if we had really bad feedback and we could just evolve on that. Because it's the first game, you kind of tend to go, okay, so if I did something wrong, what does it happen? Like, it's
a learning experience. The whole thing is, I mean, the added pressure we have is Team 17 are backing us, so we get that added pressure of there's a publisher involved.
And
so,
they did great games in
they've
the
made
past,
awesome
and you want to
games.
have like that great experience to be
the
given.
bar was already quite high for what we were trying to achieve. Now we've got to achieve and then some to meet the bar that is expected of them summer games. So it's a very stressful, but it's also fun. It's been awesome. The whole process has been great, to be honest.
I'm pretty grateful of the opportunity, honestly. I mean, I think we've been lucky as well, so that was good.
Roberta, with Light set for release this year, do you have any other upcoming projects that you can discuss with us?
That's a tough one. Do you want another project? No, we're actually working on Oculus Rift, so we'll probably be doing a lot of prototypes, experimenting with Oculus, and probably expanding on the procedural water prototype.
I'm about hiring people and then grow the business organically. That's the way we want to do it.
I see. And Dan, considering there are so many other great game engines out there, why does Just a Pixel choose to work with Unity?
To be honest, Unity was the engine I started using pretty much at the beginning, like way back when I started developing about 3-4 years ago now. I think Unity was the one I started like really getting on with. It's all C# based. It's got a nice usability. Sort of anyone can pick it up and play with it. The designers can easily interact with it. It feels like the better engine for me. I mean, there's pros and cons of every engine. I mean, I'm not saying that this is better than UDK. I'm just saying, personally, it fits my development style, and we understand the engine way more than we understand UDK. So it's not so much this one's better. It's just I like working with it. I understand it. So that's why we use it.
I see. And Dan, you're a speaker at tonight's LUUG. And can you tell us quickly what you're going to be talking about?
It's going to be going over the basics of procedural generation, mostly going over how the problems I run into when I was like starting to make it, and I just really want to start a discussion about how to make procedural stuff. I'm not the expert here. I want to get people talking about it. So maybe that way there's more information about it, so other people can start making stuff like this. That's it.
Thank you. I look forward to your talk later. Thank you. Thank you so much.
Thank you.
So this is all about how not to make procedural generation, basically. I made prototypes to sort of play around with it and how to learn how to do this stuff. So this is all my personal experiences. I'm no means an expert. I just have messed around with this, and I thought that this stuff needs to be told to people. Anyway, my name's Danny Goodayle. I'm the co-founder of Just a Pixel. Like I said, these are my personal experiences. Anyway, so what is procedural generation? Generation is basically anything that can be written by code. So meshes, music, text, basically anything. You can make entire stories with procedural generation. They probably won't be any good, but they'll still be stories nonetheless. A lot of games use it, like Dwarf Fortress, for instance, is one of the ones I know quite well. Is it's all generated, everything, including the history, the lore, all the content except for maybe the characters, maybe not. No Man's Sky is the one that's just at E3. It's all generated by procedural software. I don't quite understand how they do it, but it's crazy. And of course Minecraft, but most of that's using just standard Perlin noise with like three different layers. Unity has a mesh filter, right? I had to kind of learn all this stuff on the fly. So mesh filters are the storage of the mesh data. So you have vertices, you have triangles, you have UVs, normals. Vertices can be just an array of 3D points like vectors, so X, Y, Z positions. Triangles are indexes to the vertices, so it tells you which order to render them in. So, and then, yeah, they're always 3 times larger than the vert, because you need to have a triangle which is 3 times more than a vert. Let's try and explain this stuff. Right. To draw a triangle, you have to define the order of which you render them. So you have 0, 1, 3, and that will give you a clockwise motion, which means that it's going to render forward. If you was to do that the other way around, it would render backwards. And now my laptop's died. So, no, there you go. In order to make a quad, you need 2 tries, and they have to always be in this sort of situation, and they always have to be in clockwise order. So that makes sense for that one. Vertices. If you share vertices, like on a face, like so you have these 4 like this one, this one, this one, this one. If they share the same verts when you define the triangles, if you define the same vertice here to be using the same like literal position point, the normals will not work out correctly, and the lighting will go like that. Like that on the left, basically, it will turn out like that.
I ran into that the hard way with trying to do plane modeling, and everything looked weird and strange, so I just kind of found out that shared vertices are really bad things. Random numbers in computing is not random. It's you set a seed number, and that generates a sort of cache of numbers that you pick out. So you always pick up the top object. So these are actually numbers that are based in Unity. So if you give the random seed of 1, you'll get these 3 numbers always. Like as long as you set the seed as 1, and then you get the next numbers. You can do it over and over again. You'll always return the same numbers. So that's how people share like seeded worlds. They can sort of generate them on the fly, and they'll always be the same for everyone. Unity has a Perlin noise function, which I didn't know about. So Perlin noise is you pass in an x and a y value, and you return like a value between 0 and 1, which is really handy for like generating 3D worlds. So if I passed in an x and y coordinate, I could guarantee that I'd get the same one back every time I generated it, no matter where it was. So if I was generating a mesh that was to the left of another mesh, I could always get the same height position. There's also libnoise.net, which is an open source noise library, which has every type of noise I've ever heard of. 3D and 4D noise, so you have like a 3-dimensional noise where you have it in heights and different locations, and 4D if you want to have time in there as well. You have complete control over the generation as well. Perlin noise, you don't really get any control. It's just you pass in the numbers. You don't really get like a seed for it. Okay, so that was, I generated a mesh, and then I put the heights in using the Perlin noise between 0 and 1. I've already said that. And then to make waves, I just did the same thing, but I used an offset with a sine wave, and it just generates like a wave sort of motion, which is really handy. And then if you tile things, if you generate things at runtime, it's quite slow. It's quite expensive to do at runtime. So what I tended to do was build the mesh once, and then I tiled it like 9 times around the camera. So the camera would always have the center point, and then the mesh would always have tiles around it. That way, instead of instantiating at runtime, I'm just recycling the ones that are behind you or out of focus. So you just reposition them all the time. And don't update. So the water will be updated at runtime constantly. Every frame it will be doing a sine wave on every single vert. You don't need to do that on everything. So if you do renderer.isVisible, you can technically, you don't need to render it. It won't be visible, so why update it? It just kind of saves a little calculation. So you can generate off anything. Like as long as you've made a mesh before, you can sort of learn how to turn like OpenStreetMap data into like cities like this. This was generated all purely based on I got an XML document with a load of points and paths, and you can turn that into the meshes that you see there. Like it contains longitude and latitude. You have to then map that into Unity's 3D space, which is quite fun. Veroni diagrams. A game called So You're Being Hunted basically made their entire worlds using Veroni diagrams, which take a set of points and works out the distances between them, and then finds the edges between them. So if you could easily look up how close you are to another point based on these edges. It generates worlds that look roughly like this, like they're all triangles and nice organic shapes, but you can also define roads along the edges, and it looks quite nice to generate cities. L systems as well. They're great for generating the entire cities. It's like rule-based generation. You pass in A and AB, and B returns A. So then the first iteration you put in A, then the next iteration would be AB, then be ABA. And it just generates. You can generate like entire tree structures with this. I mean, most tree generation algorithms are run off like an L system. I've kind of run through that incredibly quickly. Sorry about that. Right, any questions? And I'm just going to quickly show you this thing. So this is the world I was talking about. It's incredibly slow on a laptop, but it has a little day-night cycle when everything flows around. This is like a work in progress. We're trying to figure out what we're actually going to do with this. It's sort of, we made this to have fun and learn, and now I'm trying to explain why I did this to people, and I have no idea. It's kind of just said it was fun to make, and then I kind of just rambled on for about 20 minutes explaining why. So it has a day-night cycle, looks all pretty. And then there's also the city generation one. which was all based off this OpenStreetMap data. It generates this all at runtime. I don't know if anyone recognizes these buildings. This is all in Manhattan. So some of the map data is most of it's user generated. So people are submitting this content, like the outlines of the buildings. And most of the time they're okay with that sort of guessing the heights, but some people just decided that some buildings are ridiculously high. Like, I'm pretty sure this is not what Manhattan looks like. So, but they've kind of guessed the heights, so I'm just kind of letting them off with that one. So I can pass in any OpenStreetMap data with this, and it will generate a 3D city for it. So we've got downtown London, we've got Brighton, we've got anywhere that this map data is, we can sort of generate it for people. The idea with this is we wanted to have it so you can click the buildings and then go inside them and do like a subversion style game where you can break into little worlds and stuff, but it just ended up getting too complicated. I didn't want to spend the next 6 months trying to figure out how to do that when I could just make a new game. Like, just finish one complicated game, I don't need to make another. But yeah, that's my, I guess, really basic overview of procedural generation. If you have any questions, just do ask, and then I'll probably put you in touch with people who know more than I do.